Think about the distance between the Earth and the Sun. It's roughly 150 billion meters. Now think about something at the complete opposite end of the scale, the size of an average human cell, which is about 0.0007 of a centimeter. One of these numbers is extremely large, the other is extremely small, and both are difficult to write out, to read, and to compare. Imagine writing 150 billion in full, counting every zero, or trying to write 0.0007. It becomes very easy to make a mistake. This is exactly the problem that standard form solves. Instead of writing all those zeros, we write that large distance as 1.5 times 10 to the power of 11 and that small cell as 7 times 10 to the power of minus 4. The same numbers in a far more manageable form. So whenever you are dealing with a number that is extremely large or extremely small, standard form is the method that lets you write it, compare it, and work with it accurately. Hi, welcome to My Exam Revision. In this video, we'll be discussing standard form. This video is divided into 3 parts. In the first part, we'll look at how to convert any number into standard form, whether it's a very big number or a very small one. In the second part, we'll look at how to add and subtract numbers in standard form. And in the last part, we'll look at how to multiply and divide numbers in standard form.
I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Now, let's get started. Let's begin with the first part, converting numbers into standard form. Before we do that, let's be clear about what the finished form actually looks like. Every number in standard form is written as a number multiplied by 10 raised to a power. We write it as a times 10 to the power of n. There are 2 rules that go with this. The first is that a, the number at the front, must be at least 1 but less than 10. So it can be 1, it can be 9.9, but it cannot be 10 and it cannot be smaller than 1. The second is that n, the power, can be any whole number, positive or negative. A positive power means the original number was large, a negative power means it was small. Keep those 2 rules in mind because everything we do today comes back to them. Now there are 2 cases here, converting a large number and converting a small number. The method is almost the same for both, with one difference that I'll point out clearly. Let's start with a large number. Suppose we want to convert 640,000 into standard form. Step 1. Place the decimal point straight after the first non-zero digit. The first non-zero digit is 6, so we put the decimal after the 6, which gives us 6.4. Step 2. Count how many places the decimal point has moved. In 640,000, the decimal sits right at the end, and to reach its new position, it moves 5 places to the left, so the power is 5. Step 3. Write it out. 6.4 times 10 to the power of 5. And because the original number was large, the power is positive. That's the pattern to remember. Now let's do a small number, because this is where students lose marks. Suppose we want to convert 0.0072 into standard form. Step 1 is the same. Place the decimal after the first non-zero digit. The first non-zero digit is 7, so we write 7.2. Step 2. Count how many places the decimal moved. This time it moves 3 places to the right to reach its new position. Step 3. Write it out. But here is the important thing you need to remember. Because the original number was small, less than 1, the power is negative. So the answer is 7.2 times 10 to the power of minus 3, not plus 3. The rule is simple. Moving left gives a positive power, moving right gives a negative power. Get that one fact right and you'll never put the wrong sign on your answer. Let's do 2 more quickly to lock this in. Convert 567 million into standard form. Place the decimal after the first non-zero digit, which gives 5.67. Count how many places the decimal moves. 8 places to the left. The number is large, so the power is positive. The answer is 5.67 times 10 to the power of 8. And now a small one. Convert 0.000042. Place the decimal after the first non-zero digit, 4.2. Count the places it moves, 5 places to the right. The number is small, so the power is negative. The answer is 4.2 times 10 to the power of minus 5. Watch that minus sign carefully. Leaving it off is one of the most common mistakes in this whole topic. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, myexamrevision, I have created a full worksheet for each topic. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions, all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level Maths and further Maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now we move on to the second part, adding and subtracting in standard form. The key principle here is simple. You can only add or subtract the front numbers directly when both have the same power of 10. So the whole job is usually about getting the powers to match first. Let's take the easiest case. Add 4.3 times 10 to the power of 3 to 3.9 times 10 to the power of 3. Both numbers already have the same power of 10, which is 3, so we just add the front numbers. 4.3 plus 3.9 is 8.2. We keep the power of 10 exactly as it was. So the answer is 8.2 times 10 to the power of 3. Notice we did not touch the power at all. We only added the front numbers. Now the harder case, where the powers are different. Add 4.2 times 10 to the power of 5 to 5.1 times 10 to the power of 3. We can't add them yet because the powers don't match. So step 1 is to rewrite one of them. Let's bring the smaller one up to match the larger. 5.1 times 10 to the power of 3 can be written as 0.051 times 10 to the power of 5. The same value, just rearranged, so the power is now 5. Step 2. Now that both have a power of 5, add the front numbers. 4.2 plus 0.051 is 4.251. Step 3. Keep the power of 10 as 5. So the answer is 4.251 times 10 to the power of 5. The habit to build here is to always make the powers match before you add anything. Subtraction works in exactly the same way. If the powers are the same, just subtract the front numbers. For example, 6.8 times 10 to the power of 3 minus 2.5 times 10 to the power of 3. The powers match, so subtract. 6.8 minus 2.5 is 4.3. Keep the power of 3. The answer is 4.3 times 10 to the power of 3. And when the powers are different, you adjust first, exactly as before. Take 7.5 times 10 to the power of 6 minus 3.2 times 10 to the power of 4. Rewrite the second number so its power matches the first. 3.2 times 10 to the power of 4 becomes 0.032 times 10 to the power of 6. Now subtract the front numbers. 7.5 minus 0.032 is 7.468. Keep the power of 6. So the answer is 7.468 times 10 to the power of 6. Same rule throughout. Match the powers, then add or subtract. Let's finish this part with one more. To put it all together, add 3.2 times 10 to the power of 4 to 4.5 times 10 to the power of 3. The powers don't match, so first rewrite the second number. 4.5 times 10 to the power of 3 becomes 0.45 times 10 to the power of 4. Now the powers match, so add the front numbers. 3.2 plus 0.45 is 3.65. Keep the power of 4. So the answer is 3.65 times 10 to the power of 4. Now let's move on to the last part, multiplying and dividing. And here's some good news. This is actually easier than adding and subtracting because the powers no longer need to match. For multiplication, you do two things separately. You multiply the front numbers together and you add the powers. That's it. Let's see it. Multiply 4.5 times 10 to the power of 5 by 2.0 times 10 to the power of 2. First, multiply the front numbers. 4.5 times 2.0 is 9.0. Then add the powers. 5 plus 2 is 7. So the answer is 9.0 times 10 to the power of 7. Clean and already in standard form because 9 is between 1 and 10. But here is a case you have to watch. Multiply 6.2 times 10 to the power of 3 by 5.0 times 10 to the power of 2. Multiply the front numbers. 6.2 times 5.0 is 31. Add the powers. 3 plus 2 is 5. So far we have 31 times 10 to the power of 5. But 31 is not allowed as the front number because it's bigger than 10 and standard form needs that number to be between 1 and 10. So we adjust. 31 becomes 3.1 times 10 to the power of 1, and that extra power of 1 gets added to the 5 we already have, giving 6. So the final answer is 3.1 times 10 to the power of 6. Always check your front number at the end. If it's 10 or more, you're not finished yet. Division follows the mirror image rule. You divide the front numbers and you subtract the powers. Take 6 times 10 to the power of 8 divided by 2 times 10 to the power of 4. Divide the front numbers. 6 divided by 2 is 3. Subtract the powers. 8 minus 4 is 4. So the answer is 3 times 10 to the power of 4. Straightforward. And just like with multiplication, there's a case to be careful with. This time when the front number comes out less than 1. Take 4.5 times 10 to the power of 3 divided by 9.0 times 10 to the power of 5. Divide the front numbers. 4.5 divided by 9 is 0.5. Subtract the powers. 3 minus 5 is minus 2. So we have 0.5 times 10 to the power of minus 2. But 0.5 is less than 1. So again, it's not yet in standard form. We rewrite 0.5 as 5 times 10 to the power of minus 1. And that minus 1 combines with the minus 2 we already had, giving minus 3. So the final answer is 5 times 10 to the power of minus 3. Notice this is the same idea we used in multiplication, just in the opposite direction. There we trimmed a number that was too big, here we fix a number that was too small. And that covers all three parts. How to convert any number into standard form, how to add and subtract, and how to multiply and divide. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.